Welcome back to Josh Does Math. Today we're working with higher order derivatives, which are the derivatives of derivatives. So right here we have two functions and we're said find the first four derivatives of them. Okay, well, we know if we're looking for the first four derivatives, well, we're going to be looking for dy dx, so we can start there. Dy dx is just the derivative of the original function, assuming this is y. So what is the derivative of this? That's easy, that's just the power rule. You know how to do that. That's 24x squared plus 14x minus 1. Well, there we go. And we're looking for the first four derivatives, though, so that means we're also looking for this guy. The second derivative, the derivative of your derivative equation. So what is this thing's derivative up here? Once again, you just use the power rule, and you end up with 48x plus 14. Well, we're also looking for this guy and this guy. So what's the derivative of our second derivative? That will give us our third derivative. So that's going to be just 48. You know how to do that. And now we're looking at the fourth derivative, the derivative of our third derivative. And as you can see, it's just a constant number, so it's 0. So these are the first four derivatives for this function here. Now I'm just going to erase this so that I can use the same four derivative things that I wrote down right here for the second problem. So for this problem down here, once again, we're looking for the first four derivatives. You can start off easy with the first derivative. So what is the first derivative? Well, you just use the power rule a bunch of times. And that's what you get. So as you can see, we started off with a fourth degree polynomial. So that's x to the fourth as the highest power of x. And after taking the derivative, we ended up getting a third degree polynomial. And you can see that pattern is going to go on. We're going to get a polynomial back after taking the derivative that is one smaller in degree number than the one before it. So this will get a second degree polynomial, a first degree polynomial, so just a linear equation. And we're finally going to get a constant for the last one. So if we look for the second derivative, we're just taking the derivative of what we have up here. So that's going to be 12x squared minus 78x plus 10. And then derivative of 3 is just 0. So you can see that each time also, since the powers of x originally were each one smaller than the other in our original equation here, see how it's x to the fourth, x to the third, x squared, x, and finally you could say x to the 0 were just constant. Each time that we take the derivative, since it's set up this way where x decreases by 1 the whole way through the polynomial, we're going to be cutting off a term each time we take the derivative. So for this next one here, for the third derivative, you can expect that it's going to be only 2 terms now. And let's look for that right now. Using the power rule, we get 24x minus 78. And there's our 2 terms. And if we take the derivative once again and get down to a constant value, it's just going to be 1 term. So that's going to be 24. So that's how you do a higher order derivative problem like this, where they're asking for derivatives of derivatives. It would be really hard if they asked just what is the fourth derivative of this function, because then you would need to take all the derivatives to get there. But since they say what are the first 4 derivatives, well, that's easy because you just work in the order. You don't need to skip around or anything. That would be hard. Instead, you just work through each derivative in succession, one after the other, and that's how you can finally get down to your 4th derivative that you wanted. Thanks for watching.